Knock, knock. Who's there? Orange. Orange, you glad I didn't say cast in place? Hello, we're the Orange team, Team Metromont. I'm Ethan Lowndes.
My name is Liz Rodriguez.
This is AJ Bania.
I am Brady Andrews.
Yeah, so Franklinton is in a state of revitalization, as you've kind of heard. And a lot of good programs like the Franklinton Development Association and the Link Us Columbus program that's trying to run a bus transit through there are kind of big in that effort. And there's no better spot to kind of put a site for a community inreach center than the current site of the Franklinton Development Association's office, which is on Broad Street, which is a big main throughway in Franklinton. And then so this is our kind of vision for what a community center would be, and we're calling it the TETRA Community Center. Set in a residential area, we kind of wanted to use shifting masses to not only kind of create open green spaces, but also kind of step up towards our largest structure, which is our parking structure. With that, it kind of splits our structure into two. You have the Broad Street side, which has houses kind of office and kitchen areas, and then on the south side it's more recreational and another garden area. There's circulation through, on the Broad Street side you have circulation that kind of weaves through that and then connects to the parking garage with a classic Columbus sky bridge, and then as well as circulation on the back side. To kind of quickly run through our program, on the Broad Street area we have the offices, which are the Franklinton offices, which are currently there. We're going to keep those there, as well as provide a homeless resource center. That kind of goes into a dining area with a kitchen, as well as a food bank. And that kind of then steps up towards the library, which would be a branch of the Columbus Metropolitan Library, and then as well as educational spaces, gathering, other study spaces, and kind of meeting spaces. On the south side of the parking garage is where we get into the recreational area. We have a multi-purpose gymnasium that also serves as a FEMA shelter, has a suspended track around it, and with that comes other recreational areas, yoga studios, spin classes, and other kind of kids gathering areas, kids play spaces to kind of serve the community. And then that kind of steps down to the end of our site, where we have a community garden at the end, and then kind of a building that serves as a gathering area and also as a market for a farmer's market on certain days.
So when coming up with our design, we really had to think about the spaces that needed to be functional, but also how could we represent Franklinton? And so when looking at the community, there's a lot of art in the area, and we took inspiration from that. We came up with the TETRA panel made out of precast, and so we really wanted to showcase the diversity, and when we looked at the show floor, Endicott provided that for us. They were able to give us 4 different colored bricks. They were able to vary the percentages that they could give it to us, so finding a way to build this community one brick at a time was kind of the way that our concept kind of developed. And the overall concrete mixture behind the thin brick came about with learning more about Sika and what makes an admixture functional. So it needs water, cement, sand, gravel, as well as chemical admixtures, fibers, and other additives. So one of the ones that we did go forward with was Sika Rapid, which would accelerate the admixture, and that would accelerate the whole process to where we could remove the formwork at a faster rate in order to erect this more rapidly. We also looked at Sika, the pre-fiber concrete, which would decrease the cracks and reduce them as well. When looking at form liners for the thin brick, we went forward with form liners, architectural polymers. They were able to provide a variation and bring our idea into action. So the panel width that we went with was 12 foot. The maximum height that we could go up to was 65 feet, but of course, because there are residential single-family homes on two sides of the site, we did not want to go all the way to that height. When looking at the elevations, the top one is from South Glenwood Avenue. As you can see, the parking deck is in the middle. We wanted to have access to both the front of the end, where we would have the offices, the dining area, the library, but as well as towards the right back end of it, where it would be the recreational spaces. We also wanted to incorporate more of the art local to the area. So the panels that are on the parking deck are inspired by Elizabeth Miller's artwork. The elevation at the bottom, facing from West Broad Street, is what you would see from the most congested street, the front. And as you can see, there's a lot of deviation within the brick and how it's just coming down, kind of as if you were in it playing Tetris, placing one brick at a time. When looking more into the thin brick, we really wanted to see how we could vary the color of the overall look of each building. So in the front, where Broad Street is, right across, there is a fire department. They mainly use some similar variation to that of burgundy sands. So we wanted to incorporate the majority of that percentage in that building. And then towards the back end, where the recreational, the 7 building, we wanted to incorporate more of the graphite, the gray sands, which was similar to the residential homes near that area. So that would incorporate more of that percentage, just kind of varying the percentage of the thin brick in each building gradually.
We have 7 buildings from a structural engineering perspective, and all these 7 buildings were designed making use of Ohio Building Code 2017, which follows IBC 2015 with some amendment. So this project site, Columbus, Ohio, receives 20 pounds per square feet of snow, which is the ground snow, and it also receives 150 miles per hour wind. But we also have emergency shelter, which falls under risk category 4 for IBC, and it has to be designed for 250 miles per hour. And because the risk categories for this building, particular emergency shelter, which is one among the 7 buildings, will have to be designed for STCC. That's why the shear wall will be intermediate precast shear wall for just that building, and other buildings will have ordinary precast shear wall. And because this project site was flooded in the past, I just wanted to make sure if we are still good for flood design, and because of the flood wall, now FEMA has categorized this location in flood zone X, which is beyond the 500-year flood, so we don't have to design the building for the flood load. The overall scope, engineering scope of this project is to design all the gravity members, and based on the gravity members, all the seismic weight of the building will be determined for all 7 buildings. And based on those numbers, all 7 buildings will be analyzed for wind and seismic. And based on those analysis, all those gravity and lateral force members will be designed for wind and seismic forces. And after that, all the sizes will be provided to pre-configured pricing, and then the load coming to the foundation will be sent to the engineer of the record for the design of the foundation. For the gravity members like columns, beams, worst case situation were obtained from IBC 2015, worst case load combination of dead load, live load, roof lights, and snow. For the design, snow of 25 PSF with the drift has been considered because the building is stepping down, and we also have some parapets. And live load were received from IBC, and based on all those load combinations, all the 7 buildings were designed for gravity. And the beams were double Ts. None of those double Ts were more than 32 inches. That gives the architects to about 10 feet of clear height for the building. And also 1 foot for HVAC and all the electrical and fire. Then to support those double Ts, there are inverted T beams and L beams on the side, and to support those girders, the column size 24 inches by 24 inches with reinforcement of number 4 bars, number 11 bar, 4 of them. And also, these columns could be smaller, but at the same time, just wanted to make it consistent for easier production. And it also helps with the connection details. And also, like for all the lateral force resisting system, the core members, collector members, shear walls were also designed from the IBC worst case load combination of wind and seismic. And as you can see in the diagram, you have shear forces coming from either wind or seismic. The portion on the right, which is the gymnasium, also the shelter, emergency shelter, does have wind coming in range of 240 kips. That was a design challenge, and for that, the shear wall is size 12 inches with number 4 bar at 12 inches. And based on those numbers, we've done collector design as well, which is not over here. And all of the members were designed for seismic. All of the 6 buildings were controlled for seismic. And for the connection details, we have presented some examples. This is, for example, one of the shear wall on the parking garage. The one in just in between the green one with 165 at the opposite, because it's only 36 inches long. The overturning is quite significant with the tensile force of 106 kips. And for that, we went to the trade floor and spoke to the professionals in there, and NMB splice sleeve offers some connections, 9UX, that can resist, if I use 3 of them with number 8 bars, it can resist 106 kips. And similarly, I have some typical design connections, which is this connection came from ALP Supply, and on the left is for the T-beam resting on the core bell, which is QC10 core bell, and on the right you can see a stealth connector, which can be used to connect the shear wall, and it also has a good tensile capacity and shear capacity as well. But this is just a typical connection, which pretty much covers for all walls except for the 12-inch wall. Thank you.
So when thinking about a site, you gotta think about the logistics. And our main focus on this site was we wanted someone to be able to look at this and not see it as a concept, but see it as something that could actually be built. With our site logistics, I broke it down into 3 separate phases. Phase 1, we're gonna have the offices, education, library, and kitchen. Phase 2 is gonna be the parking garage only. And then phase 3 is going to be the gym rec and the 2 recreational areas. The thought process with this was Broad Street's a very heavily trafficked area, and we wanted to work our way off that main road. So we were going to use Glenwood as our main haul road, and we are going to do a 1-lane closure for our hauling and dropping off of panels. With working our way through the phases, we're going to be using a 300-ton crawl crane. And going to be backing up all the way to phase 3 off that site. Just south of the existing apartment that's across the street from Glenwood Avenue, we're going to be incorporating a laydown yard and a drop lot that we will be renting out in phase 3 for the deconstruction of the crane, as well as dropping off any material. I would also like to add, off of Glenwood Avenue, there is a existing power line that runs the whole span of the road. So we are going to do temporary power to relieve the safety precautions with the crane being in there. In our schedule, I have for a total project duration of 110 days, broken up into those 3 phases. The great thing about precast material is that you can shorten your durations with production time. So in our schedule, we only have just the erection of the building as well as production time of the panels. So phase 1 will have 42 days, phase 2 will have 39 days, and phase 3 will have 29 days. We have a start duration of the earliest of March 13th. That way it's after winter and we can finish by August 11th. I've also included a project cost into this, so we have 3 main items that we looked at, which was the precast material, as well as project direction, and then including a price for that crawl crane. So phase 1, we're going to be just over just under $3.2 million, and phase 2, we're going to be just over $1.1 million, and phase 3, we're going to be at $1.4 million. with a crane mobilization of $50,000 to cover any costs added into there. So a total project cost of just under $5.7 million. We would like to say thank you to the PCI Foundation, and we hope you enjoyed our presentation. And we are Team Metromont.